Let's take a look at the different ways to start Z-Attack Proxy in the user interface of the tool. You are given multiple ways to start the software. First, through a standard executable, which is pretty straightforward. I'm pretty sure everyone watching this has seen this before, so no surprise here. Next, because ZAP is a Java-based application, there's a jar file that uses the Java JRE you installed to execute. For Linux users, we have a shell script file available, and finally, a standard Windows batch file. What is nice about all these methods is that you have command line options available to help customize your experience if needed. Running any of the launch methods mentioned in the last slide opens ZAP with the default settings you previously provided. But ZAP provides some options you can play with to set up various features or edit standard settings upon execution. I'm going to cover some of the commands I have used in the past here, and I will refer you to the wiki, which I will talk about how to access at the end of this clip for the full list of options and associated description. The config option gives you the most control over the program. There is a config.xml file that contains the configuration settings of ZAP. These XML keys can be manipulated with the config option. The daemon option allows you to start ZAP in the background. Need to change a host setting? Need to change a port setting? Two settings that can be easily adjusted without having to navigate the menus. New session forces ZAP to open a new session along with what name you want to set for that session. Finally, the session option allows you to select a previous session to refer back to. So, what are these sessions I am referring to in these last couple options? From the time you open ZAP, all the activity that takes place is recorded in a local database, and sessions allow you to refer back to it at a later time. I test multiple applications with ZAP, and I set up different sessions for each app. If I need to answer questions on the work that has been completed, if I want to pick up where I left off on something, or in my case, if I test an app on a regular recurring schedule, it is nice to have something set up for me so I can just jump in and go. Let's walk through ZAP and the layout of the UI, starting with the sessions. Right off the bat, you will see a pop-up box when you start the application, a simple question asking if you want to persist the session. If you are going to be doing some quick and forgettable work, then simply leave it on the default of no, I do not want to persist my session at the moment. If the work you'll be completing is part of an ongoing customer engagement, or if you're in charge of reviewing the security of an application you own and will be reviewing it on the schedule, then persisting your session may be the way to go. The question is then, do you want to date and timestamp the session file, or do you want to name the session file in a more personalized manner? Once you make your selection, click Start and off we go. The application is split into three main work areas, plus the menu and toolbar area at the top. The toolbar contains all the most common tools used in the ZAP, making it easier for you to do things you need to do in a more streamlined way. One of the first settings you want to change as we enter ZAP is the mode of attack found in the toolbar. There are 4 settings here. By default, ZAP starts in standard mode, which I am uncomfortable with, as it allows you to do anything to any site. Attack mode takes that a step further and actively scans any site in scope as it is discovered. The opposite end of the spectrum is safe mode. This shuts off any potential harmful tool inside a ZAP. Finally, we have protected mode. This is the mode I like to set ZAP to as I enter the application. This mode will allow you to perform actions on sites in scope. The mode can be persisted between sessions and keeps you from accidentally scanning a site or part of a site you didn't mean to. In addition to the menu at the top, the bulk of all actions you can take are easily accessible by right-clicking on the various spots of the interface. The context menu pops up and the items highlighted are what are available for that area of the screen. This is super cool as you basically have all the power of the application at your fingertips with a simple click. The tree window on the left starts out with just the Sites tab. All the sites, CDNs, scripts, everything you access while the proxy is turned on fills this area up, and believe me, it can get ugly and confusing fast. There is a very important feature in this section to keep you on track and organized. As websites populate this area, we don't want to accidentally scan the wrong site because, I don't know, people may get upset if you do that, but we'll talk about that later. Well, the context feature allows you to narrow the scope of your work down and only display the URLs for the site you specifically select to scan. We'll cover context in greater detail later when we talk about prepping for the attack. The workspace window is where the bulk of your hands-on work will take place. You start out with 4 tabs. Quick Start is open by default. This allows you to jump in and perform an active scan of whatever URL you input. It starts by spidering the target, then performing an active scan. You're going to hear me mention active and passive scanning throughout some of this course. Passive scanning looks at all the responses that return from the server and scans them for any known vulnerabilities. A passive scan does not change the content or data, so it is safe to run in the background as you work. Active scans are direct attacks on the web application. Just a reminder, only use this feature on sites you have permission to test. Active scans perform functions on a pen test that can be automated and can be seen as malicious intrusion attempt. The request, response, and break tabs will be your main work areas. Here you'll be able to see content passing back and forth on the browser to the server and be able to edit parameters, cookies, tokens, and so on. We will have fun with this section in a later module. The tabs are broken into two sections. The top section displays the request headers, cookies, and URL information. The bottom section displays the rest of the parameters passed, including the post parameters. Finally, the bottom information window contains all the useful evidence and results of the functions you carry out. The three tabs open by default are the History tab, which orders every call being made while the proxy is turned on, allowing you to refer back to any piece of activity and review the request and response information. The Alerts tab displays all the vulnerabilities found in the code throughout the active and passive scans take place. And finally, the Output tab simply contains various informational messages. As we start to work and get deeper and deeper into the application, all these areas of the interface will start to open more tabs, giving you more functionality by opening up more and more of the right-click context menu. For more information on everything we just covered, visit the ZAP Wiki. It is easily accessible when the proxy is turned on and ZAP is running. Open a browser and navigate to http://zap, and you're done. The group behind the ZAP tool have put together a very helpful wiki. This should be your first place to reference if you ever get stuck or need an idea. So, to review, persistent session, yes to save, no for temp work. The tree window on the left is where we will be setting the context and targeting the application. The workspace window at the top displays the information behind all the requests, responses, and scripts you collect. The information window will give you the history of all the pages you visited and potentially pulled into ZAP. As you get deeper into ZAP, this is the area where all the tabs for the different functions will start to pop up. Last but not least, don't forget about the toolbar. This is where we set the attack mode when we enter ZAP, and as we move along deeper, various functions are controlled here.